Hi guys and welcome, Gnembon here. You probably didn't know that, but I am currently on vacation with my kids, but in the meantime I challenged myself to come up with a solution to a very interesting redstone problem. And I can't wait to share my solution with all of you guys. It probably only looks to you like a wall of chests, and that's good because that's what it's supposed to look like, but as you probably read in the title, it is a wall of chests that have a built-in multi-item sorting system. It works in principle in a similar fashion to Tango multi-item sorting system, which I'll point to in the down there, so you can look up his tutorial for some details. This one amplifies on the features and frankly the drawbacks of the Tango's design as well. In short, each chest has to be filled up with items you want to sort, and they have to be stackable, but you can mix and match different items within each chest. So you can, for example, put all your redstone stuff in one chest and all your clays in the other. The first benefit of this design comparing to the others is that this not only allows you to stack chests on top of each other, but also next to each other. The maximum dimension of a unit of this contraption without any major modifications is 8 wide and 16 high, which we have here just behind this full build. It is questionable though how would you reach to the chests up the top, but in theory you could sort here 128 double chests of items, which is just shy of 6,000 stacks of items you can sort individually. And with some sort of ladder system in place, this might look actually pretty good. In terms of the amplified drawbacks, at first, again, we have its speed. Traditional single item sorting systems work with the speed of hoppers, which means one item per 4 ticks. Tango's column sorter has 10 tick clock powering the system, and this one requires a 16 tick clock, meaning that with the full size system like this one 8x16, it'll take about 7 minutes to sort one item. I wouldn't build it that high though. More practical heights are implemented in full here, which is 5 high and 8 wide, and it takes about 2 minutes for an item to cleanly go through it. Second drawback is the noise. Traditional systems are silent. Other multi-item sorting systems have this quite annoying ticking noise from the droppers. This one adds pistons moving, albeit pistons noises doesn't seem to be that bothering comparing to the ticking of the droppers. And this design uses a similar number of droppers per chest compared to column-based sorting solutions, which is roughly 1 dropper per 1 chest. In turn, if you have items that you farm in large quantities due to the noise and speed of the system, I would prefer using traditional sorting methods for them. Also, if you trickle slowly items from a slower farm into it, you'll constantly hear the sorting noise of the sorter, which might be pretty annoying. This design also suffers from the same other problems of the other multi-item sorting systems. When the system is sorting items, when you open a trapped chest, and half of them here are trapped chests, it will lock the hopper behind it, and if there are items currently flowing through it, it will lock it and create a small backlog of items, which may cause some of them miss their respective chests. Let's demonstrate the backlog problem. Here we have a few chests that will accept redstone. Ideally, all the redstone items should be sorted into the first available chest. But if we create a small backlog and run the system, we can see that half of the items missed the target chest and went further through the system to the next available chest. But enough with the negative stuff. The system is perfect for a personal storage system where you come after a build or a mining session and drop all your items into a chest and simply forget about it. Also, the sound of droppers and piston dissipates quite quickly. Providing you are not standing next to the sorter all the time, it should be fine to use it for your small personal farms as well. Let's now look at the principle behind the sorting. To be able to sort items individually, we need a wall of hoppers facing away into the storage chest in front of them. Behind the hoppers we have a wall of redstone blocks which lock all the hoppers so they cannot suck items from the hoppers above them. In this case we also have two chests that we sort items into, one that accepts slime balls and other for redstone. The last chest, which is left empty, is our default item chest for all the other items that doesn't get sorted. When we place a slime block in the top hopper, it stays there because all the hoppers are locked. If we move the entire row of redstone blocks behind the hopper below it, it depowers the hopper in that row for a few ticks, allowing the hoppers in front of them to perform an operation, which in this case is to suck an item into them. The second time we move redstone blocks behind them, they are allowed to perform a second operation, and if there is no items above them, they'll try to push an item into the chest if they can. To have it optimized speed-wise, we need 5 ticks of lack of power for a hopper to perform those two operations, since hoppers have a 4-tick cooldown period before they can perform next operation. To move blocks using a piston takes 3 ticks, so moving redstone blocks back and forth provides us 6 ticks of the power, which is enough. Then we need 2 ticks of cooldown for all the hoppers to lock, so we can switch to the other line of redstone blocks. 1 tick should theoretically be enough, but some items go through unsorted. 2 ticks cooldown makes it work 100% of the time. Moving the line of redstone blocks is one part of the cycle, and we have to repeat it for the other line, so in total the system will be operating on a 16-tick clock, with the piston firing 3 ticks apart and the other column firing 5 ticks after the previous one, which is 3 ticks required for the piston to move blocks plus 2-tick cooldown. Also, for our contra pistons to be able to push the redstone block, the first piston has to be fully retracted, so all the pistons should be powered with short 1 or 2 tick pulses. So if we put the redstone dust in the sorter, we can see that the first chest is skipped, since the hopper behind it is not able to place it in the chest. But the second chest is able to accept an item, so it pushes it there. If we try again with some dirt, it won't be accepted to any of the chests and lands in our default chest. If we look at the back, we can see that we need to alternate the position of the pistons so we can power each individual line without powering the lines above and below them. Also, we need zigzag of neutral blocks just in front of the pistons to avoid powering and butt powering other pistons with the redstone blocks. This is the reason behind the 8 wide design limit for the system. A piston can push 12 blocks, but 3 of them have to be neutral in each row, and we need 1 extra column of redstone blocks to make sure that there is always a redstone block behind each hopper, regardless how pistons move them. Once the items make it to the bottom of the contraption, we need to push them back to the next column of hoppers. So we need to have a wall of droppers facing up behind, but not touching the redstone blocks. Since droppers are full blocks and can transmit redstone power, they will be powering each other, so we need to space them and provide power from the redstone blocks using repeaters like so. Using power from redstone blocks makes the system compact, but if one has more space, the droppers could be also powered from the back for a more silent solution. Next challenge is to pipe the items into next column of chests once they flow down from the previous ones. We can either weave it on top or at the bottom, or with the assumption that the maximum width is 80 chests, we can weave them at the bottom and top in this pattern to achieve the flat design, with a space between the columns of droppers in the middle of the contraption. I used an alternating clays which I placed on top of the hopper pipes, on top or at the bottom of the build. The input pipe, the first pipe from the input chest, goes around like so, and then the other 3 squeeze next to it. Once we reach the midpoint, the weave continues at the bottom, with the first line going around the dropper and the next one squeezing next to it. The repeaters between redstone blocks and the droppers power most of the droppers, but some of them still needs extra power due to how weirdly droppers powering works in Minecraft. So make sure that in your system all the items can go up the droppers regardless how you power them, so you might need to experiment a bit. Now let's switch to the pulse circuit. It is definitely not the most compact design, but since it's modular you can move it anywhere you have space in your place. Behind the droppers, below them, wherever you need. You can also easily replace components for other types so that suits your needs better. I'll actually present later two more alternatives to this design that you can use instead, but if you come up with a more compact design, please let me know in the comments below. As mentioned before, the entire contraption has to be powered by a 16-tick clock, which is here on the green clay. I am using a standard comparator clock with repeaters set to 4 and 3 ticks, and the last tick comes from the comparator itself. The clock signal goes to the rising edge monostable circuit here on the cyan or gray, whatever you like, clay, which shortens the pulse to 1 tick. Then we have a pulse circuit that generates 4 pulses that trigger appropriate lines 3, 5, and then 3 ticks behind the previous one. The use of multiple repeaters is required to maintain a short pulse length up to 2 ticks. I actually cheated here a bit. Instead of having 5-tick delay here between those two lines, I have 4 ticks, so I need to delay the final signal that goes to the slab towers on these lines by 1 more tick. Yellow and red lines control each alternating row of pistons and push them back and forth in the rhythm that we have come up earlier. Those alternating rows of pistons are triggered simultaneously using 2 slab towers, powering each one of them individually from the back and from the side, ensuring that they are not powering nor butt powering pistons from other lines. Other option for the timing circuit is to use the same clock sideways to separate signals immediately to the left and the right side. Then use 2 monostable circuits here for a change on the falling edge, and then one needs to create enough delay to space the signals apart. This solution takes less space but requires longer input lines to fit all the extra repeaters that will put the signals on the respective lines 8 ticks apart. Since it's a 16 clock, other option would be to use 4 hoppers arranged in a circle. And since it already generates 4 different pulses, it might be quite handy to use. Here I am also using 4 rising edge monostable circuits using sticky pistons to shorten the pulses. This setup can also power the pistons in the correct sequence for the sorter. The input to the system is triggered by items placed in the input chest, so I collect the readout from the first dropper, where the items will be backing, waiting for their turn to go through the system. This powers this line, which goes through this repeater into the storage tower, which keeps the clock running, providing there are still items needed to be sorted in that bottom dropper. Other part is optional, but I think highly recommended for all your personal storage solutions, which is the falling edge pulse extender. It makes sure that the system is running for a set amount of time once the last item leaves the first bottom dropper, and there is nothing else to be sorted. If your system is mainly for sorting your automated farm drops and you don't mind if some of the items will be still in the pipes before they'll finally make it to the respective chests, you can leave this bit off. It will actually make your sorter run shorter because it won't be going on just to sort out your last items. Otherwise, if you drop even a single item, the system would need to run for a few minutes to clear all the droppers and hoppers. I'm using an Ethos hopper timer pulse extender triggered by a falling edge of the input from the input dropper, and the output of the pulse extender goes up to power the clock the same way it was powered while the items were still waiting to be sorted. The number of items you need to put into it depends on the time it takes for an item to go through the system, divided by 2 because the items in the hopper timer clock need to go back and forth to reset it. To measure how long it takes to go through your build, you can use the following setup. You need to fill all the sorted chests except the last default chest, which needs to be empty. Then you need to put a hopper fitting into your input chest with a block on top with a lever attached to it, which needs to be turned on. Then we run a redstone line that will go into a hopper, which is also connected to the output of the comparator, measuring when an item shows up in your output chest. Then we need two chests, one of them for the items to count and the second for the result. Then you need to fill up the top chest with some random items, couple stacks would do. Then we need to power the system in a permanent manner. And when you are ready, put an item that is not sorted in the system, flip the lever and let the item go. This enables this hopper, which allows the item to go into the result chest, and once the item lands in the last chest, it will lock again the hopper. Once it's done, you can easily divide the results in half and put half of it with a few bits to spare in the pulse extender. That's all what you need to know how to build this kind of sorting solution in your world. Now the only problem you will have with all your items would be how to label all those chests, since there is no space here for the signs or item frames. So if you liked the video, please leave a like, share with others on whatever you use for sharing, and subscribe for more technical Minecraft videos, and see you in the next one. Bye bye!